We know that a resistor offers resistance to the flow of electrons. Let us study what are the factors which affect the resistance. Let's check the effect of radius or diameter of the resistance wire, length of resistance wire, and the material of resistance wire on the amount of resistance offered. We have a circuit connected to a battery, plug key, milliammeter, and a resistor in series. A resistor of nichrome wire with a unit length L and a unit diameter D connected in the circuit. Insert the plug key and observe. We see that 18 milliampere current is flowing through the resistor. With this as the reference, double the length of the resistor coil and observe the amount of current flow. We see that 9 milliampere current is flowing through the resistor, which implies that with the increase in length, there is decrease in current flow. This means that as the length of the resistor increases, the resistance also increases. Double the diameter with a unit length L and observe. We can see that the current flowing through the resistor is now 36 milliampere, which implies that as the diameter of the resistor increases, the resistance decreases, resulting in increase of the current flow. Now, use a copper wire of unit length L and unit diameter D. We can see that it is allowing more current to flow. Since we have changed the material of the resistor from nichrome to copper, we can say that the different materials offer different resistance to the flow of current of same length and diameter. Hence, we find that the resistance depends on the material, length and diameter of the resistor. It is directly proportional to the length and inversely proportional to the diameter of the resistor.